Mrs. Gale, are you trying to make a daisy chain again?
No, not today. I'm something quite different actually, Miss Mia.
What are you doing?
Just putting these daisies in Mr. James's basket.
Mr. James's basket.
He's had a tough day.
He's had a very tough day. Shall we get on with the lesson?
Yeah, let's get on.
All right, let's go.
Hello boys and girls, welcome back. It's Miss Mia and
Mrs. Gale.
I bet you're sick of us saying that because you know exactly who we are. We're back here to teach you some more maths, so should we get started?
Yeah, let's get started.
All right.
So, slightly different starter today. So let's just zoom in to see what Thinking Tom says.
When we say zoom in, Miss Mia, pick up the camera,
Yeah.
break your arm and have a go.
We're really high tech at the school. So what we've got here is we've got a measurement question and you're drawing upon your knowledge on area. So a couple of weeks ago we did a lesson on area, so you're kind of going back to that long-term memory. So Thinking Tom says, if I double the lengths of the sides of a triangle, the area will double. So I'll read that again.
You look a bit like Thinking Tom.
I'll be quiet. That one. That's you, more like you. Okay, let's look at that statement again. If I double the lengths of the sides of a triangle, the area will double. And what do you think? You have to convince me. So I'm going to show you a layout that you could use at home, and you would need to probably do 2 or 3 examples before you could be able to justify your thoughts on this. So,
Just gonna
the
put the
first
camera
thing I
down.
need to do is I need to remember what is the formula for calculating the area of a triangle.
Do you remember, Mrs. Gale?
I can remember it, thank goodness. But can you remember it at home? What is the formula? So pause the video. Can you say the formula for calculating the area, the inside part of a triangle? Okay. And Miss Mia, what would you say your formula is? Because there's lots of different ways of saying this.
I'd say base times height divided by 2.
That's exactly what I would say. Another way might be base times height, half your answer. Right. So formula, and the algebraic formula would be base times height divided by 2, okay? So that's how you would write it if you were going to write it in algebra, because you know that this fraction line means division, okay? And you wouldn't have to write the base times height. You could also write it, because when you do multiplying both of these, you could have BH, which means when you have 2 letters together, you multiply, divided by 2. So that's another way of writing the formula. Okay.
Glad we got that sorted.
Right, so it's up there to remind yourself of what you need to do. So I've just drawn 2 triangles here. I've not drawn them to scale.
Not to scale,
So
because
it's
that
really
confused
important.
me.
Yeah, I know, Miss Mia couldn't get her head around that. So what I'm first of all going to do is I'm going to give this triangle some measurements, okay? And I'm going to go with multiples of 2 because they're easier to double. So I'm going to imagine that this length here would be 4 centimetres. Let's say that this length here will be 6 centimetres. And well, actually, I don't need this length here. This is the hypotenuse for area. I just need base times height, okay?
Shall we do the double of the length
Yeah.
there first?
So that's what I have to do. He said if I double the length of the sides, so Miss Mia, double 4 would give me what?
8
8. What's my units of measurement here?
centimetres.
Okay. And double 6 would give me?
12 centimetres.
Okay. Now I'm going to work out the areas for these 2 triangles, and he's telling me that if I double it, if I double the lengths, the area will be doubled. Well, let's have a look and see if see what we think after one example. So to calculate the area of this triangle, I'm going to do 6 times 4, which gives me 24, and then I'm going to divide it by 2 or half it. So 24 halved, or divided by 2, gives me 12. So the area is 12 centimetres squared, because don't forget it's units of measurement.
Okay.
Okay, Miss Mia, have a go at this one.
Thank you. So for here, I need to do 12 multiplied by 8, which is 96. And then I do 96 divided by 2, so I'm halving it, which equals a 48 centimetre squared. So I'll write it inside.
Yeah.
48 centimetre squared.
Now he's saying if I double the lengths, the area will be double. Is 48, Miss Mia, double 12?
No, because double 12 would be 24.
Okay, so in this instant, it doesn't work. But actually, one example isn't enough to convince anybody, especially in
And
maths.
it's enough to convince me, but not Mrs. Gale.
No, you need to have a few more examples, probably like 3, 4 or 5 examples to really get an opinion and be able to justify it, because you might actually find that with certain measurements it may work. However, some of you might see something already and think actually you don't need to do any more because I already know this. However, what I would like you to do is you can draw out some triangles. You don't have to draw them to scale. You don't have to draw them accurate or anything. I just did some right angle triangles just because it was easier to do the base and the height without the hypotenuse, which is that diagonal line. So I would do here, question 2, put some measurements in. Question 3, put some measurements in, double them, see what the area is for those triangles. Now, whilst you're pausing the video at home, Miss Mia's going to have a go calculating some of her own.
I know you did multiples of 2 here. I'm going to go with multiples of 3 for this one, just to see if it makes a difference.
With odd numbers.
With odd numbers.
Yeah, that's a good idea.
I'm going to go with 3 centimetres here, and I'm going to go with 9 centimetres here. Obviously, it's not drawn to scale. So double would be 6 centimetres, and then double 9 would be 18 centimetres. Okay, so to work out the area for this particular triangle would be the following. So I need to do 9 times 3, which equals 27, and then 27 divided by 2, which equals 13.5 centimetres. So I'm just going to write 13.5 centimetres squared. And then here, it's slightly longer, the actual calculation. So I'm going to use a calculator. You should not be using a calculator. So I'm going to type in 18 times 6, which is 18 times 6, which equals 108. And then I need to do 108 divided by 2, which equals 54 centimetre squared. So again, I can make a comparison. Well, I have actually doubled these lengths. The area of this triangle is 13.5 centimetres squared, and the area of this one is 54 centimetres squared, and actually that's not double. 54 is not double of 13.5 centimetres squared. So far I've got 2 examples actually disagreeing with this particular statement. I'm just going to do one more. I might do multiples of 4, so I'm going to go with 4 centimetres and 8 centimetres here. So this will be 8 and this will be 16. Hopefully you're doing your own at home. So the area of this triangle would be 8 times 4, which equals 8 32, and then half of 32 is 16 centimetres squared. And then again here I'm just going to use my trusty calculator. Please do not use one at home. Use your short multiplication if you need to. So 16 times 8, which equals 128 centimetres. And then I need to divide that by 2. So dividing it by 2 would equal 64 centimetre squared. And again I can compare these areas, and it's really glaringly obvious to see that actually 64 is not double of 16 centimetres squared. Now I've got enough information here, so 3 examples now, to actually state the following. Thinking Tom is in fact incorrect. Alright, we're back and we're joined by Mrs. Gale again. So we had the statement, so if I double the length of the size of a triangle, the area will double. Obviously I've got 3 examples here and they all disagree with the statement, and Mrs. Gale is now going to explain why that is the case.
Okay, so here it's not going to be double the answer, okay? It's just not going to work, and the reason here is because you've got that dividing by 2 in the equation. So actually what's happening here is if I did 12 times 2, which would give me 24, instead of dividing it by 2, I then need to double 24, which would give me 48 to get the area, if it's double the size. Okay, and that works with these ones here. If I've got 13.5, if I double 13.5, I actually get 27. And then if I do 27 times by 2, it gives me 54. Okay, and the last one here, what did we have here? 16. We had 16, double 16 is 32. 32 doubled again is 64. So actually each time I'm actually multiplying it by 4 to get my final answer. So his statement is incorrect.
So we could say, if you made the statement, if I double the length of the size of a triangle, the area will quadruple or get bigger by 4, that statement would then be correct.
Yeah.
Okay, so hopefully, boys and girls, you notice something similar. And shall we crack on?
Yeah, let's move on.
Let's move on.
Okay, good starter. All right, Ello.
To answer multi-step questions involving decimals linked to measures.
Okay. Now, This first one, in order to be able to answer this question, we need to practice. What are you doing?
Measuring you. Practicing my measuring.
Not that. And that's
No.
not even accurate measuring.
Oh.
God, jeez.
Lisa tried.
Oh man, those kids are going to learn nothing. Right, okay. So let's move on. This is a 2-marker question. So the first skill we need to practice is to subtract a decimal up to 2 dp. Miss Mia, what does 2 dp mean?
I don't know, are you trying to be street?
No.
It means up to 2 decimal places.
Okay, so Miss Mia, can you give me a decimal which has 2 decimal places afterwards?
Of course I can. 1.26.
Okay, 1.26. And why would you say that is an example of 2 decimal places?
Because it's got 2 digits after the decimal point.
Okay, so this is 2 decimal places. So Miss Mia, just give me another one. That is
3.75.
Okay. And we know that's a 2 decimal place. Why, Miss Mia?
Because there are 2 digits after the decimal point.
Okay, so we're just looking at subtracting a decimal up to 2 decimal places. So that's what we're looking at from a whole number. Another
Or
word.
an integer.
Great. Okay. So
That
let's
was a
have
weird
look.
way of you saying
It was,
word.
it just came out. So question 1 here, let's have a look at it. We've got 5 subtract 2.32. Okay, or 5 minus 2.32.
Now when you subtract, Mrs. Gale, you always start with the largest number, don't you?
And the largest number is what, Miss Mia?
5.
Okay. Now, actually, some of you will need to be really careful about where you place your digits. Okay. So 5 is equivalent to 5.00. And the reason why I'm going to change it to a whole number with 2 decimal places is because I'm subtracting a decimal with 2 decimal places. Okay. So I put 5.00. Now that 2 must go under the 5 because actually that's the ones column. The 3 is in the tenths column and the 2 is in the hundredths column. Sometimes we will see a pupil write it like this. They might have, Miss Mia, there's numerous mistakes wrong with that particular way. At home, have a think, why is this read an incorrect way of writing this calculation?
Because you wrote it.
No, a bit more than that. Miss Mia, why would this be an incorrect way? There's so many reasons.
Well, first of all, if you look at the number 2.32, the integer 2 is clearly smaller than 5, and 5 is larger than 2. So actually, the 5 is in the incorrect column, because at the moment it's in the hundredths column, and it should be in the ones column. That's one mistake. Equally, the number, when you're subtracting, you need to have the largest number on top. So the 5 should actually be on top, just like you have in the purple, because it's greater than 5.00 is greater than 2.32. You could do this calculation, but you wouldn't get the right answer. You'd have a completely different answer. And equally, if you did 2.32 minus 5.00, you'd get an answer, maybe a negative answer.
Yeah, thank you, Miss Mia. So that's not the way we want to lay out our work. It's really important that we lay it out in the correct method. So, okay, so we know there's going to be borrowing here because there's 2 zeros. So, can't do, let's put our number operation there. 0 minus 2, can't do. Can't borrow from here, can't borrow, must borrow from here. So the 5 becomes a 4. I give that 1 over, I carry it over into this column. However, I'm borrowing again, it therefore becomes a 9, and this becomes a 10. Okay? 10 minus 2 gives me 8. 9 minus 3 gives me 6. I must put in that decimal point. It doesn't look like a comma. And 4 minus 2 is 2. So 5 subtract 2.32 equals 2.68. And I could check that. Okay? I could check that by using the inverse. And I'm going to do it in a different colour.
I could actually give you a different strategy, Mrs. Gale.
Go on.
You could do 0.32 plus 0.68, and that should give you 1 whole. And then you can add the 2 wholes together, so the 2, 2, and the 1 whole, and that should give you 5.
Yeah.
If you wanted to do it mentally.
Mentally, yeah.
But the inverse would be the following, Mrs.
Yes.
Gale. Off you go.
What you don't want to do is do it mentally and then be inaccurate with this calculation because this is a skill. You need the skill to be applying it. So the checking strategy would be, what would I do with my answer here, Miss Mia, and this number?
You'd add them together.
Okay.
And you want to get the target of 5.00 or 5.
Okay. So if I had 2.68 plus 2.32, I know that 8 plus 2 is 10. 6 plus 3 plus 1 gives me 10, decimal point. Cross it off. 2 plus 2 is 4, plus the 1 gives me 5. It's 5.00, which is equate to 5. So this 2.68, I know, is accurate.
Okay.
Okay. So, Miss Mia, you've got one there, just another one.
Okay. Shall I give it a go?
Yeah.
All right, no worries. So I'm just getting used to this, boys and girls. I'm slowly getting used to it. Right, so I've got 6 subtract 3.25. I know that 6 is greater than 3.25, so the 6 needs to be on top. So I'm going to go with 6.00. So I've got my decimal point with the placeholders, so 2 placeholders there. Subtract 3.25. Put my subtraction. I always put in my decimal point before I do the calculation, because then I know I won't forget. Obviously, I can't do 0 take away 5. I can't borrow from the 0 next door, so I'm going to borrow from the 6. So the 6 becomes a 5. This becomes 10. I need to borrow from the 10. That becomes a 9. This becomes 10. 10 take away 5 is 5. 9 take away 2 is 7. And then 5 take away 3 is 2. So the answer is 2.75. I'm just going to use a checking strategy here, so I'll use a different coloured pen to check my work. So I'm going to do the following calculation: 2.75 plus 3.25, and it should give me the answer of 6. So let's have a look. Decimal point. 5 add 5 is 10. 7 add 2 is 9 add the 1 is 10. 2 add 3 is 5 add the 1 is 6. So I know that that is accurate. Are you happy with that, Mrs. Gale?
Yeah, very happy with that. Some of you will be able to do it slightly mentally in terms of checking as well. And Miss Mia mentioned that earlier. So in my head I was thinking 0.75 plus 0.25 gives me the same as a whole. Okay, I know that. And actually I know that 3 plus 2 gives me 5 plus the whole will give me 6. Okay, so I could do that mentally as well.
But I know that some of you try and do it in your heads and you make lots of basic errors, so please do the calculations.
And it's really important that if you don't get these 4 correct, you go back and have some of your own, create some of your own sums and calculate them, because you have to get this accurate in order to be able to apply it to the next stage. It's really important. So we've got 4 questions here for you.
Pause the video here and have a go. Right, Mrs. Gale, are you ready?
Yeah.
Let's measure you up.
No.
Have you got them accurate?
Fail.
Let's go.
Okay, 5 minus 3.48 gives you 1.52.
Yep. 6 minus 4.81 gives you 1.19.
Okay, 7 minus 5.28 gives you 1.72.
And 8 minus, magic finger,
Magic finger.
8 minus 6.57 gives you 1.43.
Okay, so hopefully you're accurate with them. If you made one error, go back and see where is it that you made the error, recalculate it, make sure you can get it accurate. If you've made a lot of errors there and you think I haven't got them correct,
Rewatch the start of this video.
yeah, rewatch it, have a go at those 4 again, and then you might want to ask your parents or somebody or brothers or sisters or whoever's in your household maybe to give you a couple more, but do keep to a whole number less than 10 and a decimal number that is only up to 2 decimal places, nothing more than that, because that's the skill that you need. Okay, it's quite
And these
specific.
questions actually come up in your arithmetic paper as well.
Yes,
so
they do.
we've already looked at this particular skill anyway, so it's good revision. Mrs. Gale, what are you going to do? You're going to model it.
I'm going to now apply skill 1, which was in terms of subtracting a 2 decimal place decimal from a whole number. Okay. However, this is a multi-step word problem here. Jacob cuts 4 meters of ribbon into 3 pieces. The length of the first piece is 1.28. The length of the second piece is 1.65. Work out the length of the third piece. So there's quite a lot of calculations in here. I am going to use the bar model to explain what the process is, because quite often students will read that question and they might hazard a guess as to what number operation they need. And actually you can't really guess because there's only one clear answer for it. So with my bar model, what I'm going to do is over to the side here, I'm going to model it, and I'm going to do any calculations I need to in this box here, because I have to show my method in order to get those full 2 marks. Okay? So Jacob cuts a 4 meter piece of ribbon into 3 pieces. So he's got this piece of ribbon here, which is 4 meters. He then cuts it into 3 pieces. So 1, 2, 3. The length of the first piece is 1.28. So this is 1.28 meters. The length of the second piece is 1.65, so this is 1.65. They want to know, work out the length of the third piece. They want to know, what is this missing length? Okay, so what do I need to do first? Well, actually, first of all, I need to add these 2 amounts here. I need to do 1.28 plus 1.65. Okay, and the reason why is because I'm looking at the difference here. Okay, and difference is then subtracting. So I'm going to add these 2 amounts and subtract it from 4 meters. Okay, so 8 plus 5 gives me 13, carry the 1. 6 plus 2 gives me 8, plus the 1 gives me 9. 1 plus 1 gives me 2. So actually what I found out here is these two parts added together gives me a total of 2.93. So therefore, to get this part, I need to look at the original number, which was 4 meters, subtract 2.93 from 4, which is going to give me this amount. Okay, so it's the second part of my problem. I know that 4 is equivalent to 4.00 minus my adding together 2.93.
So now you're applying that skill, aren't you,
Yeah,
Mrs.
and this
Gill?
is the application of skill 1. Can't do 0 minus 3, cannot borrow from here, must borrow from the 4. I'm going to use Miss Mia's skill of putting the decimal point first. I cannot miss that decimal point out. This becomes a 3, 10, then becomes a 9, 1. Okay, 10 minus 3 gives me 7, 9 minus 9 gives me 0, 3 minus 2 gives me 1. My final answer, therefore, in meters is 1.07 meters. Okay.
You cannot write your answer in centimetres because it will not accept the answer.
Yeah, so if I wrote it at 107, they're not going to give you the mark. Okay?
Well, that's not, is that correct in centimetres? Yeah. Yeah.
Yeah. Could check it, because if I did 1.7 plus 2.93, it should give me a total of 4. Okay, let's just quickly check that. So 2.93 plus 1.07. 7 plus 3 gives me 10. 9 plus 1 gives me 10, carry the 1, decimal point, 2, 3, 4. Okay, 2 plus 1 plus 1 gives me 4, so therefore it's equivalent to 4 meters. So this is correct. I know it's correct from my checking method.
I really like your use of the bar model there, Mrs. Gill. Very visual.
Yeah, the bar model is really useful for some people that don't see what you need to do. Okay, some of you won't need the bar model. You kind of know what you need to do, but what you don't want to do here is just jot random answers because you're doing mental calculations. You must show the examiner what you're doing.
And I love how you are setting out your work really clearly, and you can see the different steps and the way you're underlining or identifying the key piece of information.
Okay. Thank you, Miss Mia. This is worth 2 marks here. Okay. So if you made an error in your final answer here, but you did the right calculations, you were doing like adding and subtraction, you get 1 mark. If you were doing something like multiplying or dividing and you're not using anything linked to the number operation, which is adding and subtraction, you get 0 marks.
And
Okay.
equally, if you don't write anything here and you write something completely different, like 1.06, for example, because you're doing it in your head, you'd get 0 marks.
Yeah.
Okay?
It's
So it's really important you show your working out.
Okay,
Right.
so what we want you to do now is go along to the home learning. I know that Miss Mia, do you want to show what they've got?
Yeah, absolutely. So if you need to re-watch this example, Mrs. Gill did a really good model there. And actually have a look on the home learning page. This will be up there. So there are 8 questions in total related to the one that Mrs. Gill has modelled. And if you have a look at question number 1, for example, it just says the following. Harry cuts 5 metres of string into 3 pieces. The first length is 1.16 metres. The length of the second is 2.65 metres. Work out the length of the third. So you'll see that in all 8 questions that actually this amount here, the original length of the string, does change, does differ. Okay? So please, and also how many pieces he cuts it into. So please read the questions carefully. So this one, for example, says, good old Alan cuts a 4 metre length of pipe into 4 pieces. The lengths of the first and second pieces add up to 1.24 metres. So listen to that carefully because it's quite a lot of things you need to do for this particular question. The length of the third piece is 1.05 metres. Work out the length of the fourth. Okay?
And I think for that one there, Miss Mia, before we actually go back, I was thinking there was a help me one here. In fact, it was a show me one, and it was that question too. And I actually think it would probably be a good idea
For me to show them.
Okay, boys and girls, so we'll have a look at this question then. So Mrs. Gill has already modelled a question, but this is the second question in the set that you have to complete. And it says the following. Alan cuts a 4 metre length of pipe into 4 pieces. The lengths of the first and the second pieces add up to 1.24 metres. The length of the third piece is 1.05 metres. Work out the length of the fourth piece. So if you want to pause your video here and have a go yourself, please do so. But I'm going to model the answer in the next few seconds. Okay. So over here, just behind this shade, I have got a bar model. So if you have a look at my bar, at the top I've got 4 meters. Now the reason why I have that number 4 at the top is the following. So if I go back to my question, Alan cuts 4 meters, a 4 meter length of pipe. Okay, so that's really, really important. If I carry on and go back to my bar, if I scroll down even more, I've got 4 sections to my bar. Again, if I go back, it says here very clearly that he cuts it into 4 pieces. Okay, really important there. You can see that there, 4 pieces. I'll just move that along so you can see. He then says the lengths of the first and second pieces add up to 1.24 meters. So if you have a look at my diagram, I have drawn a red rectangle around 2 of the pieces, and I know that these 2 pieces add up to 1.24 meters. It tells me here. So the first and second, so that's number 1 and number 2, add up to 1.24 meters. It then carries on and says that the third piece is 1.05 meters. So my bar, I've got that 1.05 meters as well. So the first 2 add up to 1.24 meters, and the third one is 1.05 meters. So we need to work out, as it says quite clearly here, the length of the 4th piece. So I need to work out the missing value of this piece. So if I just grab a pen and I can show you exactly which block I'm trying to work out the value for. So it's this piece here that I need to work out the missing value for. Okay? Because we already know the first 3. It's been given to us in the actual question. So if I carry on, what I need to do first of all is the following. So in order to work out the value of that purple part, I need to add these 2 values together. I've used column addition here to add them together, so I need to work out what these 3 equal in total. So I've got 1.24 plus 1.05, which gives me 2.29 meters. Okay, so I know that combined, all 3 of these give me a total of 2.29 meters. So to work out the missing value here, I need to use my skill number 1. So I need to subtract 2.29 meters from 4 meters to work out this missing value. So I've got a calculation here, column subtraction. So I've got my 4 on top because that is the biggest digit. I've got my 2.29 meters here. So obviously I can't do 0 subtract 9. I can't borrow from the 0. So I've borrowed from the 4. That becomes a 3. This becomes a 10. We cross it out. Becomes a 9. And then this here becomes a 10. 10 take away 9 is 1. 9 take away 2 is 7. And 3 take away 2 is 1. So I know that this here, this missing value here, is actually 1.71 meters. So my final answer is the following, and I can get rid of my units here because it's already given me my units in the answer box. So my final answer is the 4th piece is 1.71 meters. Now if I really wanted to check my answer, I could just do the following. I could add this value together and this value together, and it should give me the answer of 4. So if we have a go, if we try that out, so I'm just going to get a pen, get a green pen. I'll draw my little line there, decimal point first, another line here. So I know, I'm adding as well, so I'll put the operation in. I know that 9 add 1 is 10, so 1 down there, 0 here. I know that 7 add 2 is 9, add the 1 is 10. So again, put that down here, excuse my pen. Then I know that 2 add 1 is 3, add the 1 is 4. So in fact, my answer of 1.71 is absolutely accurate, because if you add all those digits together, all those lengths together, it gives you the total of 4. So hopefully, boys and girls, that was a very clear explanation as to how to complete this style of question. So Mrs. Gale went through one and I've gone through another one. Okay, so carry on watching the video. So thank you very much for watching. Hopefully you've got a good understanding now. You can crack on with the work, and we'll see you all soon.
See you soon. Bye.
Bye.